Hi, in this short video we're going to talk about binomial products, multiplying things like x plus 3 times x plus 5, and even higher level 2x plus 3 times x minus 2. How do we work with the terms, how do we work with the signs, and how do we get our final product? Well, let's just get started. Alright, let's start with the basics. Probably you wondering from the previous screen, well, what is an x plus 3? Well, it's pretty hard to see. An x plus 3 is later on is a part of an equation or a graph, but for now we're just working at the basics. So it's essentially we're looking at an x tile, the green tiles, I'm sorry these aren't color coded, and 3 units. And that would be an x plus 3. And what is an x plus 2? Well, same idea. This would be 1 x tile and 2 white tiles. So we can represent them using the algebra tiles. The question is how do we multiply these together? All right, let's have a look at this. I've set up the x plus 3 and the x plus 2 around an empty space because we're going to fill in that space. So we're looking for the idea, how do we multiply x plus 3 times x plus 2? Well, we do it bit by bit. And so the first part is to say, what is an x times an x? Well, an x times an x is an x squared. So that gives us one big x squared tile. Then we ask ourselves, well, what is x times 1? Well, x times 1 is x. And we repeat that 3 times because we have 3 x's. Now we go in the other direction. What's x times 1? Well, x again and x again. Now we have the little ones. What's 1 times 1? 1. And we repeat that 6 times till we fill in all the squares. Of course, in tiles, these would be perfect and all together. But nonetheless, here's what we have. We have now the question separated from the answer. So now what we do is we collect up like terms. So we have 1x squared plus 1, 2, 3, 4, 5 x's, so 5x, and 1, 2, 3, 4, 5, 6 units. So what is x plus 3 times x plus 2? X squared plus 5x plus 6. Let's look at the relationship between the numbers for a minute so we can see this pattern. What is 3 times 2? 6, that's your last number. And what's 3 plus 2? 5, that's your x's. All right, let's look at that another way. All right, here's the next progression. Let's look at this with the same model, but without the tiles. And let's replace the tiles with variables. So where I had a blue tile, or my green tile, sorry, I have an x, so that would be there. And my 3 units, I just have a 3. And this would be my other x, and this would be my 2. All right, so let's just fill in the inside now. What is x times x? X squared. What's 3 times x? 3x. X times 2, 2x. 3 times 2 is 6. Well, now we have some like terms. We can add up along the diagonal. And so we have 1x squared plus 5x plus 6. Of course, we got the same answer as before. We've just done it algebraically. I call this method tic-tac-toe. Those of you who know me in class know I'm a big fan of using this method over other methods. People call it foiling or rainbow rule. Those all work fine. This method works really great when you get bigger questions, and we're going to do a bigger one in a little bit. All right, let's have a look at this question using algebra tiles, or, my hand-drawn version of them, which is equivalent. So let's set up 2x plus 1. So in this case, this one will be a little different because we're going to have 1x, 2x, and 1 unit. And in this case, we'll have x. Now, minus 2, I'll try to show with red. All right. So now we're going to do is we're going to fill this in. So same idea. What's x times x? An x squared. And what's x times x is an x squared. So now I have 2x squared as my answer. What is x times 1? Well, that's an x. Here's where things get interesting. So what is x times minus 1? Minus x. And so all of these will be red. Now, what is negative 1 times 1? Well, that's negative 1 as well. All right, so what happens now is we have to take away some 0 pairs. So let's work out our final answer. Well, this one's easy. We just have 2x squareds. Make sure you put a 2 there. Remember from class we talked about a 0 pair being a positive and a negative. So now I'm left with minus 3x's, and I'm left with minus 2. So what is 2x plus 1 times x minus 2? It's 2x squared minus 3x minus 2. All right, let's do the same question using the tic-tac-toe method. So again, filling in the 4 squares, collecting like terms, and writing our final answer. 2x times x is 2x squared. 1 times x is x. 2x times minus 2 is minus 4x. And 1 times minus 2 is minus 2. Here's our diagonal. So we're left with 2x squared minus 4x plus 1x is minus 3x minus 2. So there you have it. There's a couple of examples of how to use expansion using algebra tiles and tic-tac-toe. Here's a special case of factoring, which we've talked about, difference of squares. So let's set this one up. We'd have an x plus 2 and an x minus 2. Now let's do the expansion. X times x is x squared, and these will be both x's. X times minus 1 is going to give you minus x, and then we're going to have minus times plus is minus. Now, let's look at our zero pairs for a minute, because things get interesting. Negative, positive combo, positive, negative, they're gone. Look, our x's have disappeared. So we're left with x squared minus 4. This is a special case of a binomial, which is difference of squares. And this could look in a lot of different forms, but this is the basic way we handle difference of squares. So if you get something that ends up with a negative sign in the middle and two perfect squares, so you can also write this as x squared minus 2 squared, which shows the perfect squares on both sides, then you have difference of squares. All right, let's look at difference of squares again, this time using good old tic-tac-toe. So I've set up x plus 2 on the top, x minus 2 going down the side. So now I'm left with x squared, 2x minus 2x, and minus 4. This way you can see right away minus 2x plus 2x is 0, and you're left with x squared minus 4. Or you can write it as x squared minus 2 squared if you're looking for that pattern. So there you have it. All right, here's a higher level question that will come up a lot when we start to do higher level expansion. So the question is how do you do this in an organized way? Well, again, we can leave that up to tic-tac-toe to help us organize. So instead of having 2 columns, we're going to have 3 columns. So that's how it gets set up. Now we just multiply. 2x squared times x is 2x cubed. 3x times x is 3x squared, and 3x minus 4x squared minus 6x minus 2. All right, let's collect up our like terms. You'll see there's a great pattern that's going to form here. 2x cubed, and on your diagonals, you should have the same power. So minus 4 plus 3 is minus an x squared. You can put the 1 there if you like. Here's another diagonal, and that would give you minus 3x minus 2. So the corners are always on their own. So there you have it. That's how you would be able to represent a larger tic-tac-toe in a nice organized way, and you're not going to miss any terms.